Hello, ladies and gentlemen, and today we're going to be talking about distributive property. Basically, what we're going to be doing is going over the definition of what it means and then kind of look at how we can use it to simplify some of the expressions we've seen the last couple of days. So, what is a distributive property? The distributive property, basically the definition, the textbook definition we're going to see here is that it's a number times a sum will equal the sum of two products. Now, I don't know about you, but when I hear that, I go, what the heck are you talking about, Mr. Guy? What the heck does that mean? I don't even understand that. Well, whenever we see a definition in math, there's usually a couple of different ways that we can represent it. We can talk about the word definition, or we also can go ahead and look at the definition using variables and numbers. Now, when we see the variable definition, a lot of times for people, they kind of even zone out even more and go, what does this say? I don't understand what this means. And so what we're going to do is kind of look at some examples with numbers and some other things so that we can get a good grasp on what distributive property is, okay? But what we can see here, if we look at the variable definition, is that if I have a number A multiplied by two things being added, in this case B plus C, I can change that to A times B plus A times C. I basically can say, hey, this number on the outside can be multiplied by the first thing, and then I add it to it multiplied by the second thing. Now, there's a lot of different ways that we can do that, a lot of different ways we can represent that, because remember, addition can kind of represent a lot of different things, including subtraction can just be adding a negative. So we have a lot of different ways we can show this definition. For example, here's that one I just showed. A times B plus C equals AB plus AC. I can show that over here, 4 times 6 plus 3 is really the same thing as 4 times 6 plus 4 times 3. Okay, so the 4 can be multiplied by each one, and then we add that together. Same thing if I have it listed where the number's behind. Now it's two things being added multiplied by a number. Here I have 6 plus 3 times 4. I can write that as 6 times 4 plus 3 times 4. Now, I want you to kind of ask yourself real quick, is that going to give me a different answer than the first one? Okay, 4 times 6 plus 4 times 3, 6 times 4 plus 3 times 4? No, because as you learned with the properties earlier, multiplication is commutative. We can kind of flip the order. The order doesn't matter with that. So if I have the multiplication in front, 4 times 6 plus 3, or in the back, 6 plus 3 times 4, it's not going to make a big difference in terms of my final answer. Down here, we have the same thing with our subtraction. So we have 5 times 7 minus 2. And so if I go ahead and distribute, I'm going to have 5 times 7 minus 5 times 2. And same thing if we have it in the back. In this case, the 5 is at the back. I'm going to have 7 times 5 minus 2 times 5. Now, distributive property is something we're going to run into a lot throughout the year in a lot of different contexts. So it's going to be very important that we understand how to do it. Oftentimes, I find that students will forget to do it when they see it. Sometimes they're just kind of going through a problem and they'll just start multiplying 4 times 6 and then add 3 and move on their merry way. Or when they go to multiply, they'll do 4 times 6 and forget to do the 4 times 3 and actually have that 4 get multiplied by everything and distribute. So I've come up with a way to kind of help students remember that, and I call it the double rainbow, okay, the double rainbow. Basically, when you go to distribute, what I want everybody to do is take your pencil and I want you to draw a double rainbow, the 4 to the 6 and then the 4 to the 3. Okay, same thing we did it this way, the 4 to the 3 and then the 4 to the 6. Looks like double rainbows going across the sky, okay? And what that's going to do is it's a visual reminder to remind you, oh yeah, I do the 4 times the 6, and then I do the 4 times the 3, and that's how I distribute, okay? I do the 5 times the 7, then I do the 5 times the 2, and that's how I distribute, so on and so forth, all right? Let's look at an example of how we can use distributive property, or one way to do it. One thing that you can use it for is for doing some mental math with numbers that might not seem like they're easy. For example, if I had to buy some beads for a craft project, okay, some gold, silver, and white beads, and a bag of beads costs $3.99. This happens a lot. You go to the store, something costs something 99 cents, and you want to figure out how much it's going to cost overall. Well, it's not super easy necessarily to multiply something by $3.99. Okay, if I'm getting 3 bags, multiplying 3 times $3.99, not something that's really easy. But you can break it down into some smaller or some easier numbers to work with and make an easier problem to solve. In fact, some of you might do this in your head already, and what you don't realize is you're secretly using the distributive property, okay? So for this example right here, I look at this $3.99 and I say, do you know what? I think $4 is a number that I could easily multiply by. Okay. In fact, what I'm going to do is I'm going to take 399 and rewrite it as 4 minus 0.01. If you take $4 to subtract a cent, you get $3.99. And so those are the same thing. 399 and 4 minus 0.01 is the same thing. Well, those are also much easier to multiply by. So what I now can do is draw my double rainbow, 3 times 4, 3 times the 0.01, and write that down here, 3 times 4, minus 3 times the 0.01. And then I can go ahead and do that multiplication in my head. I probably don't need a calculator. I probably don't need to sit there and go, I'm just going to estimate to figure it out. I can figure it out. 3 times 4, well, 3 times 4 is 12. And then 3 times 0.01 is going to be 0.03. And that's something I can also do. 12 minus 3 cents, well, that's going to be 11.97. Oh, hey, the cost of these beads are going to be $11.97, and I figured that out by using the distributive property. Okay, if you want to impress your mom or your dad next time you go shopping with them, do this trick. Okay, they go to buy something, it's 99 cents or 10.99 or 8.99, and they're like, "Oh, I'm getting 4 of these. How much is it going to cost?" You can be like, "Oh, I got this. I'm going to use the distributive property. Got you covered." All right. Okay, so that's one example of a real life thing that we can use the distributive property on. All right. Now, we're going to stop here for a second. This is what we're going to call a checkpoint here. Here's what I want you, ladies and gentlemen, to do. I want you to pause the video in a moment. So in a second, I'm going to say pause the video. I want you to pause the video. In your notes where you're writing stuff down, I want you to go ahead and write down these examples, and I want you to try them, all right? I want you to try them. What you're going to do is you're going to basically use my double rainbow method, okay, to try to multiply these using the distributive property. I'll do the first one for you, and then you guys can try the other ones. So like, for example, for this one, all right, well, 2 times 9 plus 4, how do I do that? Well, I can rewrite it as 2 times 9 plus 2 times 4. That's using the distributive property. And then I'll go ahead and say, all right, well, 2 times 9, that's 18. 2 times 4, that's 8. Oh, and I add those together, and I get 26. This is exactly what you should have on your paper. All those steps included. Show me you doing the distributive property, and then you combine them together and getting your answer, okay? I don't just want this plugged in your calculator and say, oh, I got the answer. We need to make sure we can do distributive property and show it in this way. We're going to be adding variables, so if you can't write it out, it's going to get really hard. All right. So I want you to go ahead and I want you to try these. For these ones down here, what you're going to do when you go to try 4, 5, and 6, just like we did with the last one, I want you to split this into 2 numbers. So for example, I would split this one into 2 numbers I can easily work with, which would be 103. And then I'll go ahead and distribute and get my answer. So for this one, draw my double rainbows. Oh yeah, 500. And then 5 times 3 is 15. Oh, and I got 515 as my answer. Okay. All right. So now what I want you to do, pause the video, go ahead and try 2, 3, 5, and 6, and then come back and check your work and see how you did. All right, ladies and gentlemen, let's go ahead and let's check our work. It's just magically appeared, all this work that I have done here. All right, so let's go ahead and let's check our answers. So for each one, for this one, I got 27 as my answer. Now you might say, Mr. Guy, how'd you get 27? Well, I want to show all this work so that we can see. I did 12 times 3 minus 3 times 3, which is 36 minus 9, or 27. Again, the distributive property, 12 times 3, 3 times 3, and then we go on through. Here I'm going to distribute the negative 4 through, so it's going to be 4 times negative 4 minus 11 times negative 4. Now for this one, 4 times negative 4 is negative 16. Negative 11 times negative 4 is a negative times a negative, which is going to turn into a positive 44. Please double check that one. If you have minus 44 there, make sure you double check that and make sure the negative times the negative is a positive. So we're going to put 28. Down here, we split the 103. Oh, we did that one already. Over here, we have 4 minus 0.2. I did 4 times 4 minus 4 times 0.2, which is 16 minus 0.8, or 15.2. And then last but not least, we have 3 times 6 plus 0.03. I split the 6 and 6.03 into 6 and 0.03. Then we do 3 times 6 plus 3 times 0.03, multiply that, and we're going to get 18.09 as our answer, okay? So that's what we're going to talk about distributive property today. You're going to go through and do the rest of the activities that are listed, and then tomorrow, what we're going to do, or the next time that we meet, we're going to talk about when we have variables added into distributive property. And it's going to keep the same pattern, the same thing we just talked about, just add in some letters for fun, all right? Thank you for watching.